Welcome everyone. So this is our 57th live stream geometry. We have 6 people here besides me and a few new people. So if you want to join sessions in the future, feel free to email me at mgreenb801@gmail.com. It's in the description of the video. And the sessions are on Sundays at 8 a.m. US Central Time. So last time I did a couple problems from the Saudi Arabia IMO team selection test. And today I'm going to do some from the Saudi Arabia Balkan Math Olympiad team selection test. So the test used to determine the participants in the Balkan Math Olympiad. And I also chose one other problem from one of the participants on our channel. That looked pretty interesting. So with that, I'm going to get started. Let me share my screen. Oh, okay. I was going to do this one second. So here's the first one I was going to do. I usually try to choose the easiest ones, or the ones that look easiest first. We'll see how easy it really is. So you have a triangle ABC, and J is the AX center. So I'll draw it like this. All right. And let me draw in the circle. And then we could draw the X circle. Guess I could do it like this. So it's I, and then if I draw the line AI, it's going to meet it at the X center. Okay, so we want to draw the midpoint of arc BAC. Okay, so we should probably use the in-center X center lemma here. So I'm going to draw the circumcircle of ABC. And basically, so N, so this is an N. Let's call this, I don't know, P. And let's say, whoops, center. Oh no, I want O to be the center of D. Sorry about that. Okay, there we go. And okay, so basically this right here is point N. It's the midpoint of arc BAC. Here's point J. It's the X center. Let me draw the X circle. Do it like this. So PICJ is cyclic, or BICJ is cyclic with center P. Might as well draw that too. So by the in-center, that's true by the in-center X center lemma. And what else do they give? So N is the midpoint of that arc. M is the midpoint of BC. So if it's the midpoint of BC, it's also the midpoint of this segment connecting the two tangencies. That's pretty well known. And T is the reflection of N over A. Interesting. And we want to show that JMIT is cyclic. Interesting. Okay, so let me make this look a little better. So we have all these points that are collinear here. And obviously angle NAP is a right angle. See, we have another new person join. Hey, Sergio, thanks for joining. So we're just on the first question, and I just drew the figure, so now I'm going to make it look a little nicer. Let me hide some things. I don't need that or this. Oh, whoops. I meant to do this. I'm going to hide that, hide that. I don't need this whole line. I can just draw part of it. And I think we are good with the figure. Okay, so I think that's it. So triangle PNP is isosceles. I don't even know if I need to draw PT, but okay. So we have the excenter, the midpoint, the incenter, and this reflection point. And we want to show that that makes a cyclic quadrilateral. All right. Let's see how we might want to do this. So the thing is, we could try to show angle JIT is equal to angle JMT. And JIT is the same as PIN. And IN actually passes through the tangency point of the mixed linear incircle. I don't know if that would help, but it's just an idea. Maybe there's some other special point too that circle passes through. So what would happen if I reflected that circle over this line? So M, basically I'd want to reflect, I think it might be easier to do that. So instead of reflecting N over AI, I can reflect M over AI and try to show that cyclic with N. I think that might be a little easier. So I'm going to try it. So like I could show J M prime I N is cyclic. Is that really easier? Maybe not. Can I use power of a point? Maybe I could extend this and then extend that and use power of a point. What happens when I do that? So if I draw this, does it pass through the intersection of these two circles? No. So do we know anything about angle JM? Let's see, we want angle JMT.
There might be something that is useful about the angle MJI.
Okay.
In some previous session, like 5 or 6 sessions ago, we proved that if you take the touch point of incircle with BC.
Let me draw it.
Then AF is parallel to MJ.
Oh yeah, I remember that. Okay. So yeah, AF is parallel to MJ. And I know I've thought about this proof so many times, but yeah, I'll just assume it's true for now. Oh, I think the proof isn't that hard. I think it's like
AF passes through the if you let the AX circle tangency point with BC.
So I draw AF.
Also draw the tangency point of AX circle with BC.
Oh, the X circle. Okay.
So AF passes through the antipode of G by homotheity.
That was it. Yeah, AF passes
Yeah.
through the antipode of G. And
Yeah,
so,
so it's midline.
okay, that makes sense. All right. So that proves that AF is parallel to MJ. So maybe that helps with the angles, because then angle JMT, that's like the angle between AF and MT. We want to show that's equal to angle JIT, which is PIT, which is PIN. But yeah, we have to figure out the angle between AF and MT then. Hold on just a second, guys. I'll be right back. All right, thanks everyone for waiting. So we have another person joining now. A lot of participants on the session. Thanks for joining, Colin. So we're still on the first problem. So you have a triangle in center, X center. Then you have the midpoint of side BC. And then you reflect this point N over point A. And you want to show JMIT is cyclic. So that's what we have so far.
Intersect AF with MT.
Okay. AF. Actually, let me just draw the segment instead of the ray. I see someone wrote something in the chat. So that's H. Oh, looks like Nguyen has a solution. So angle IMT. So Nguyen is trying to show IMT plus ITJ. IMJ plus ITJ is 180. So IMJ plus ITJ is IMJ plus INJ. So I'm going to write out what Nguyen wrote. I'm going to hide the circle for a second too. Okay, so let's see. Let me hide this. Thanks for typing it out. That makes things easy for me. Just going to add in the angles. Oh, well, let me just try this. Copy the word angle a bunch of times. And let's see how this looks. Two, three, four. Okay. So we have angle IMJ plus ITJ. That's IMJ plus INJ. Okay. And of course, we're using that as a right angle. And then that's 180. So IMJ, it's 180 minus INP minus PNJ. So, okay, that's true. So 180 minus INP minus PNJ. So MIJ we're saying is INP. And then, okay, so that's where we use similar triangles. And then MIJ is INP and IJM is PNJ. Okay, so we have two similar triangles. So we have triangle MIP is similar to triangle INP. Yeah. So that's where we use that angle MIJ equals angle INP. And then we have, yeah, no, this is a really nice solution. And then triangle MPJ is similar to triangle JPN. And so angle IJM equals angle PNJ. And then that's where we use the two of these. So MIP and INP are similar because basically PI squared is PB squared is PM times PN. So I'll just write out that one step. So we have PI squared equals PB squared is PM times PN. And so that's kind of where we can get that similarity. So yeah, this is used in a lot of problems, that fact. And then for this one, so we have MPJ is similar to JPN. That is because, so yeah, I could say PI squared equals PJ squared equals PB squared. So we're using that PJ squared is PM times PN. And so that's where we would get that these two triangles are similar. And then we use all that information. Really nice. All right, is TMIJ harmonic or TIMJ? Is it a harmonic quadrilateral? Let's check. This would be interesting. So if we draw the tangents at T and M, let's see if they meet on AI. Looks like they do. That's interesting. So yeah, it looks like it's a harmonic quadrilateral. I don't see why right away, but that's a good thing that you found. Interesting. Maybe after the session, I'll look at that more. All right. So we'll move on.
If we have time, then we should try to prove that also.
Yeah. If we get through all the problems, yeah, we could try to prove that next. But it's a good observation. So here's a problem Stefan gave me. Do you remember where it's from?
I don't know if it is from AOPS, but I think it's a bit complicated to explain where I found this problem, because there is this school here in Serbia, mathematical grammar school, and like they have their website, and there are some resources with some problems on there. So I found there, but it isn't in English. I translated it for you.
Okay, thanks. Yeah, I think I'll just leave it as unknown source then for now. But I always appreciate everyone, proposing problems for my channel. All right, so we have the in circle, and I'll let I be the in center. And then I'm going to draw the excenter. Let me draw the whole line BC. So actually, let me actually hide this just so it doesn't show twice. So we have the line BC, and I'm going to draw the X circle. So this should be the X center right here. Okay. And then let's do this. Yeah, I wish there was a way in GeoGebra to draw the X circle automatically, but I don't think there is. Okay, so I'm going to draw in some extra points. And oh, you've seen it before. So yeah, it'll be interesting to see if you can, keep working on it in case, you think of it again. So AF and AJ are the semi-perimeter. So yeah, you both can keep doing it if you don't remember the solution. So basically, we draw a circle. I mean, we draw the circumcircle of AFJ, right? Because, or the circle with center A and radius AF equal to AJ. So it meets the line BC at M and N. And then we're saying the circumcircle of A and N is tangent to the X circle. So I'm going to want to move things around a little bit. Let's see. So let me shrink triangle ABC a little bit so that you can see the X circle. I haven't seen this before, but it looks like Prem Joshi and Stefan have. All right. So let me close this. I'm gonna hide that. Hide this. And
Well,
hide.
isn't it a little obvious?
Oh, is it? Is it obvious?
Yeah, you just take an inversion center A with radius AF square. Then it takes the X circle to itself, and then it takes the circumcircle of AMN to MN. And
Okay.
since MN is tangent to the X circle, then AMN must be a tangent to the X circle too.
So you said you take an inversion with center A and radius AF equals AJ
Yeah.
equal. Okay.
Yeah, only using that inversion and we are done.
All right. Interesting. So I'm gonna write it up quick. Yeah. So there's a lot of times we see like the inversion with radius, like, you know, if M is this midpoint of arc BC, we'll see an inversion with radius MI. But this is interesting. This is like an inversion with radius AF. So I'll just say it. It is well known that AF equals AJ equals S. And so I could say, let phi be an inversion with center A. Oh, you solved it without it. How did you do that? Or I don't know if you remember, but radius AF equals, interesting, equals AM equals AN. Then phi fixes the X circle, right? So yeah, inversion is really handy in solving a lot of problems. So it fixes the X circle, and then we want to see where it takes AMN. And so it takes AMN to the line BC, right? So it takes AMN to line BC. And so let's see. So it fixes F, it fixes J. And how do we know that it, yeah, so I know it fixes F and J. How do we know it fixes another point on the X circle?
You just gonna label any point on the X circle, then you can just draw the line
Okay.
to that point and A, and it meets the X circle at another point. Then we have the
Oops, sorry. So A, G prime, and H are collinear, and it meets it at another point, let's say. So basically it takes, let me draw the whole line, or the ray. Oh yeah, it looks like this is the point that it passes through. It's like the intersection of the topmost point with A. Or I think so. I'm not 100% sure actually if that's true, but it looks like it. Yeah. So there's actually a specific point. Well, that makes sense because H is where those two circles are tangent. So basically we're saying that like AK times AL is AJ squared by probably by similar triangles, right? Since AF and AJ are tangent to the circle. So, oh, that's right, because if inversion fixes F and J and the circle's tangent to AF and AJ, then it just has to fix it. Yeah, you're right. So, all right. All right, I am going to move on to the next one right after this. So, Serdar just joined. And so we could say BC is tangent to the X circle. And that implies, thanks for joining, Serdar. So that implies AMN is tangent to the AX circle. All right. So yeah, this is a little bit of an easy one once you know to use that inversion. So I will move on to some more problems from Saudi Arabia. All right. Okay, so we have an acute triangle with orthocenter H, and M is the midpoint of AH. That's a common idea. And so let me use this. So that should be H, not D. And then M is the midpoint of AH. And then we draw the circles that pass through H and tangent to BC at B and C. So let's think how to do that. So I guess I could do it this way. So the center should be, oh, actually, you know what? I think we could just do it kind of like this. Oh, but it's not going to pass through A. Okay, so we want to draw the perpendicular bisectors of BH and CH, and those will be the centers of those circles. All right. Oops. My GeoGebra is getting slow. So yeah, I want to make this intersection a little closer, obviously. So maybe like that. It's hard to draw a good picture. So that would be O1 and O2. So this is O1. And this is O2. And then we could draw the circles. So that's the first circle. That's the next circle. And then we draw the excenters of HMO1 and HMO2. This is interesting. So let me hide some unnecessary stuff. That looks better. Okay, so we want to draw HMO1 and HMO2. But I don't want those I don't think those points are collinear, are they? Almost
They
looks
look
like,
they are.
let's check. Yeah, it does look true. Okay, so I guess that's something we'll prove later. Okay, so once we know they're collinear, I wonder if that makes things a lot easier, because so yeah, I haven't drawn anything else with H being the orthocenter yet. So basically we want to draw the excenter. Where's my angle bisector? Oh, it looks like those bisectors intersect on the side itself. Interesting. Okay, so that's another thing we might want to prove. So I'll draw on those two, and then let me draw the excenters that we actually want. So let me draw the bisectors of AM01 and AM02, just so I can draw the excenters. Okay, so this should be X, and that should be Y. So there's a lot of things we have to prove. We have to prove that O1, M, and O2 are collinear. And then we also want to show that these bisectors intersect on the side itself, which isn't really obvious. Or it intersects O1, O2 on the side. That might actually be equivalent to the problem. I don't know. Okay.
Looks like a circumcircle of ABC concurs with the other two circles.
Oh, interesting. Okay. Let's see if we can prove that.
And also the like the circle with diameter AH also goes through the same point.
Okay, so a lot of different circles that concur. So this one, for example, looks like it passes through that point. I don't know if that's just an angle chase. And then also if we draw, let's see. Whoops.
That is actually an angle chase. I think I have proved it.
Okay.
Like if you let those two circles intersect, then we can prove that let that point name that point.
Yeah.
So if you let okay, so the point F, then I think an angle chase would give that FHC, that circumcircle is tangent to BC, and similarly for the other circle.
That makes sense. So yeah, so we could define F to be the intersection of those two circles, diameter AH and diameter ABC. So that's the Q point. I think that's what it's called. And then an angle chase would show that FHB is tangent to BC at B. Interesting.
And that angle chase uses the fact that FH passes through the antipode of A.
Okay. All right. So we know that. All right, so should I draw these two X circles?
Oh, I think that actually proves that M lies in 0102.
Really?
I think I should just tell the details. So if
Oh, yeah, because FH, yeah, it's kind of obvious then, right? Because
MF is equal to MH, and like the bisector of FH and all that stuff.
yeah, because basically if FH are those 2 points, then like O1M is going to be the perpendicular bisector of FH, and the same as O2M, because they all pass through F and H. So yeah, they're all going to be, I mean, you have right? You have all 3 of these circles passing through F and H. So yeah, whenever you have 3 circles passing through 2 points like that, the centers are going to be linear. Okay. And then I still wonder if it's obvious that the angle bisector of O1HM is concurrent with O102 and AB. All right. So, okay, so here's one of the, I don't know. Oh, it looks like the X circle passes through A. Oh, but I don't actually think that's true. I think it just is a coincidence. Wait, so we had HM01 and then HMO2. Okay. So yeah, I drew the whole X circle. Let's see. B and C. Okay, so how would we
I think that the fact that HO2 is the external angle bisector of MH01 is proven by an angle chase.
Oh, so HO2 is the external bisector of MHO1?
Yeah, you can prove that by an angle chase.
Okay.
So we define X as the point on the so through H we draw a tangent line to O2.
Okay.
So that line is a HX. Okay, we need to prove that HX is also the angle bisector.
Oh, of MHO1?
Yeah.
Okay, so basically you defined it as being the tangent line?
Yeah, then I can use the angles more easier.
Okay.
So we can calculate the angle FHX.
Okay, so angle FHX.
Yeah, we can calculate it that it is equal to FCH.
Okay, FHX is FCH once we know that tangent C. Well, we kind of define it as tangent and then we show it's a bisector. Okay.
Yeah, and FCH is, I think we can calculate it. And I don't think that it's not really that hard to calculate FCH.
Okay.
And then
yeah, probably not.
FHA is also an easy angle to chase.
Okay. So when we add the two,
And then we need to calculate XH01.
Okay.
XH01 is equal to FH01 minus FHX.
okay.
And we can calculate FH01. It is equal to 90 degrees minus FBH.
Okay.
So I think we can prove it. I haven't really tried, but you know, I have an instinct that it will work.
Okay. So that would prove that this is an angle bisector, right? Like that's all to prove this is an angle bisector, right?
Yeah.
Okay. And then once we know that, so I'm going to type that up in the end. So angle XMY is 90 degrees. I wonder, is M the midpoint of BE? I think it might be. It looks like it. Yeah, pretty sure that's true. So basically, there's a couple things we want to show. We want to show that XHAB and O102 are concurrent. And then the same on this side. And then we want to show like M is the midpoint of DE. And if we can show that this is the midpoint of XY, then I think that would prove it.
Also, the midpoint of ED thing would be equivalent to showing that AEHD is a parallelogram.
Yes, I was actually just thinking that. So yeah, that's a good point. So yeah, we want to show AEHD as a parallelogram. Interesting. These two circles almost look the same size. I wonder if that's true. Like if I move things around, are those circles the same size? It looks like it, doesn't it? I think they are.
Sorry, Michael. I think that it's quite parallel to O1, O2. It's quite obvious by ratio, using ratio.
Radical axis theorem?
Ratio.
Ratio.
Yes.
Okay.
We have H E over H S is equal to MH over ME.
MH over ME?
Yes, and equal to MH over MD.
Okay. Let me write that. Let me just type that out really quick. So HE over HX. Sorry, it's covering it up a little bit. I apologize. So did you say HE over HX is ME over HE?
ME over MH over ME.
MH over ME. Okay. Oh, because it's an external angle bisector. Okay. And then HD over HY. Yeah, we need ME equals MD. So HD over HY equals MH over MD. So yeah, once we know ME equals MD, that would solve it. Or that this is a parallelogram, of course. So yeah, can we show that HD? And the other thing is we don't even know that these really concur yet. Like we don't know that XH, AB, and O1, O2 concur. We have to prove that. HO1 HM. Yeah, I don't think it's the external angle. Yeah, exactly. I wonder that. So it's not like this is not a 90-degree angle. I agree with that. Okay, it's all right.
We need to prove that FADE is an isosceles trapezoid.
FADE. Interesting.
I think so. Maybe not.
Looks like it. Let's see. Because then that would show O1, O2 is parallel to AF. Yeah, it looks true. All right, let me move it back to the center. So what can we say about O1, O2? So yeah, it looks parallel to AF. Well, wait. It's obvious it's parallel to AF because they're both the perpendicular bisector of FH. So, and then M is also, yeah, so you're right. We want to show it's an isosceles trapezoid. So yeah, we want to show if you take the parallel to AF through M, then we want to show that it intersects AB and AC equidistant from those two. And that might just be, I wonder if that's obvious. Because is BEDC cyclic? Actually, I'm not sure about that. Oh, that's not true. But yeah, it seems it shouldn't. So what we could do is, so we know O1, O2 is parallel to AF and it passes through M. And so then we want to show ME equals MB. But the thing is, we don't even really know. Okay, so what I'm going to do is I'm going to hide HX and HY for now. Sorry. So basically, just so we don't confuse ourselves, I'm defining B and E this way, right? And actually, is DH actually tangent to that circle? DH is not tangent to that circle. So yeah, this one looked tangent, but it really wasn't. Because if we draw this one, then it's not tangent. Yeah. You're back. Let me get a one. Let's see. Whoops. All right. So yeah, how do we show MB equals ME? Is it obvious that MB equals ME?
Sorry, I think that the AEHD is parallelogram is quite obvious. But you can show step by step. First, we need to prove that O1, O2 pass through M.
But I think that's not so hard to prove because basically we could show O1, O2 pass through M because basically we showed that if we let F be the intersection of those two, the circle with diameter AH and this big circle, and we showed that BHF is tangent to BC. So basically all three of these circles right here, this one, and the other one pass through F and H. And so their centers have to be collinear. But anyways, I'm sorry, keep going.
So had you proved that? Okay, I go on. And so next we have angle BAH. So we need to prove that HE is parallel to AC, right? So we will using angle J step by step. First, we have angle AHE.
Mm-hmm.
We need to prove that angle AHE is equal to. Sorry, let me see. I had some mistake.
It's all right, take your time. So MHE, it's half of MHO1.
Yes. Let me solve again. Sorry, I had some mistake.
Okay.
I wrote my angle chase in the chat. It isn't. It haven't been fully solved, but I think I'm really close to it. Yeah, I wrote it in the chat.
So in the chat, you said angle MHE is half of MHO1. Are you defining E like in this picture? Is it the intersection of O1, O2, and AB?
No, I'm just defining it as the foot of the angle bisector.
With O1, O2, or with so the foot of with O1, O2. So basically, it's like for you, you're defining E this way, right?
Yeah, then we can calculate that MHE is equal to half of the angle AH01, and AH01 is equal to FH01 plus FHA, and then FH01, it is equal to 19 degree minus FBH. And
Okay.
we can calculate it.
So I think
O1 and O2.
So once we do that, I think we probably could show eventually that AEBH is a parallelogram. But then how do you show that AE and B are collinear?
Maybe we don't need that.
Oh, maybe we don't need that AE and B are collinear? Well, yeah, maybe we don't need it.
Wait, so we have shown that ME equals MD, right? So back to Hui's point, we can use ratio. Yeah, we solved it using ratio. So we only need ME equals MD.
Okay, so yeah, I think we don't even need to know that AE and B are collinear, right? Because once we know there's a parallelogram, then we know ME equals MB, and then we can use the ratios. Then we can use the ratios that I wrote before, right? That was it? I forgot who wrote it in the chat, but basically, yeah, because we had like because this is like an external angle bisector, so we have like HE or like HE over HX is MH over, or HX over HE is MH over ME.
XH over XE equals MH over ME.
Yeah, okay, so that, and then is that the right? I think that's right. And then YH over YD is MH over MD. Is that right? Is that the external angle bisector theorem? Do you guys know if this is correct? I think it is.
Yeah, that is true.
Okay. So yeah, it looks like we didn't even really need to know that A, E, and B are collinear. That's kind of seems kind of interesting to me. We just draw the angle bisectors. We let it intersect 102 at D and E. And then the angle chase shows that this is a parallelogram. But wait a sec, we needed to know. So wait, where did we even use B and C? Like, is this true for any circles that just pass through F and H?
We define H as the orthocenter of ABC. So that's where we use B and C. H is defined through B and C.
Through B and C, okay. But we don't need to know that A, E, and B are collinear. I guess maybe we could prove that later. But yeah, I think we might have a full solution here. So, all right, let me write this up. So let the angle bisector of AH01.
Maybe you should first write the concurrency part of the proof.
But I think what Khan was saying is that we don't need to know that AB concurs with these other points. We just,
no, I meant the point F.
Oh, the point F. Yeah, you're right. Let F be the intersection of the circle ABC and the circle with diameter AH. And then basically we could try to show angle HBC is HFB, right? So HBC is 180 minus angle C, and HFB, I see animal disjoint. HFB is, how do we calculate that? That's AFB minus 90, which is angle C minus 90, yeah. So we have angle HFB is equal to angle AFB minus 90, which is 90 minus angle C. Which is angle HBC. So
मैं ये कह रहा था वो सारे क्वेश्चन हो गए असाइनमेंट वाले.
Sorry, Animal, I think you might have the microphone on.
वो तो कुछ नहीं है अब फोन काट.
Maybe not Animal. Oh, someone has the microphone on.
हाँ PDF सेंड कर दूंगा, बाकी उनको सब चलता है, इमेज डॉक्यूमेंट, वो कोई खासी दिक्कत किसी चीज से नहीं है.
Sorry about that. I'm going to go mute Animal. All right. So let's see. So yeah, since HFB equals HBC, then yeah, let me move this stuff over, make more room. Then that means FHB is tangent to BC at B. And similarly, FHC is tangent to BC at C. All right. And so once we know that, so then we have 3 circles passing through F and H. So the circles with centers O1, O2, and M all pass through F and H. So that means those points are collinear. So O1, O2, and M are collinear. All right. And then we could, so we could say let HX and HY intersect O1, O2 at E and D. E and B, and all right, sorry about this. So then do these equalities follow right away? So by the external angle bisector theorem, we would have those two. I'm going to make it look a little nicer. So we got that one. And then we got this one. And then we do the angle chase. Okay, and then we could do, so like in the chat, now here's where the angle chase kicks in. So now I'm going to copy what Khan wrote. So we want to show HX is parallel to AD. And Khan started out like this. Whoops. It disappears. The moment I try to type it, it vanishes. Let me see what's going on. So what if I just type some of it? It types a little bit and then it disappears. Oh well. So anyways, we have angle MHE is half of angle MHO1, which is half of angle MHF plus angle FHO1, which is half of angle MHF plus 90 minus angle FBH. Let's see what this looks like. Sorry, I'm going to take this jacket off. So ultimately we wanted to show, yeah, we wanted to show that these are parallel. So if we could show angle MHE is HAD. Yeah. Yeah, basically, if we're going to do it this way, we can't just show EH is parallel to AC because we don't know that AB and C are collinear, right? You need to show that HE is parallel to AB. Does that make sense? All right, so yeah, I think there's still another step here, right? I feel like we still want to show that A, E, and B are collinear.
Do we really need to? Because I don't think that I use that fact in my angle chasing.
Oh, really? Okay. So maybe we don't need to. But then we need to show, like, did you want to show that HE is parallel to AB? Ultimately, you want to show that HE is parallel to AB, right?
Oh, I think I use it because I need to calculate angle HAD is equal to HAC. Yeah. Gosh. Yeah, I use the fact that HAD equals HAC, which we need the collinearity.
Or HAD is HAC, yeah. Or HAE is HAB. Yeah. Let's see. Um, all right. Let's see if we can show they're collinear. So I was thinking, what if we redefine E to be the intersection of AB with O1, O2, and then we show that this is an angle bisector. Or yeah, maybe we can calculate angle EAH somehow. So it's angle AEX minus AHX. And then AHX is defined to be the angle bisector. And AEX, that seems harder to do. I wonder if we want to use homophily because let's see, what do I get when I reflect H? So like, we want to use that H as the orthocenter. So if I reflect H about E, oh, sorry.
I think that HP is perpendicular to HX. Yeah, we need to prove that.
HB is perpendicular to HX. Interesting.
Yeah, so HX passes through the reflection of B over O1.
Okay.
Yeah, if we need to prove that.
So I think it's probably not hard to, you just want to show that's the right angle, right? I think that's probably just like an angle chase, right? Because, let me think about it for just a second.
Yeah, I think it is an angle chase.
Yeah, because if we know this is an angle bisector, then we just need to show that HB is also like an, yeah.
So we show that HX perpendicular to HB. So HB is perpendicular to AC. Oh yeah, we haven't even showed AD and C and Korean.
Yeah. This looks familiar though. Let me try something. So we wanted to show that AFED is cyclic. Actually, if we define it like this, then here's what I could do. I could draw the circumcircle. Actually, never mind.
It looks like we need actually some more points, so I can say draw AB and AC back.
Okay.
And then draw the feet of altitudes from B and C.
Okay.
So like lines BH and CH.
So yeah, basically where the
Yeah.
So this point and this point.
Now intersect the line through those 2 points.
Okay.
With O1, O2.
Let me just make point N a little bit farther away. All right. So
take that point of intersection. Then OH and OF look like they are tangents.
to this circle.
Yes.
Okay.
And that has a lot to do now with the harmonic quadrilaterals.
Interesting. So OH and OF look like tangents. Oops, I accidentally erased this. So FHLN is harmonic.
Oh yeah, hi, Michael. I think I've solved it. Yeah, we're just overkilling it now. It is really simple.
Okay. Hold on one second. So draw the diameter BU of O1.
Draw the yeah, diameter BU.
Okay. So this is BU. And let HU meet AB at E. All right. I'm gonna delete this just for now.
So we can see that XBHA is a trapezoid. Since BX is parallel to AH.
XBHA. Yes, XBHA is a trapezoid.
So since O1 is the midpoint, no, that isn't how. I need to draw the diameter BU.
Okay, so here's the diameter BU.
No, BU of the circle O1.
Oh, okay. I did the wrong point U. My bad. All right. So yeah, basically it looks like we want to prove it lies on the bisector, right? But actually I think that's probably obvious by an angle chase, right? That U lies on this bisector. Yeah, because we proved that XHBU is 90, or it's probably not hard to prove. So so draw that point U and then let HU intersect AB at E. Okay. So, okay. So then we have that. We can show that HE is the angle bisector. HE is parallel to AD.
So O1HE is equal to O1UH because O1H is equal to O1U. And
Okay.
angle O1UH is also equal to angle UHA since BU and AH are parallel.
Okay.
So we have HE is the angle bisector.
Okay. So let me rewrite. So I'm going to keep some of this, but so this is kind of like the conclusion. So let me move some of this down. Exactly. Yeah, I think so. So I'm going to delete this one because we're defining X and Y differently. Okay, so I'm just going to sort of copy. Okay, so no, we know this is true right here. And then let HU meet AB at E. Okay, so I'm going to show HE is the angle bisector and HE is parallel to AB. So since angle UHB is 90, it's not hard to show that HE is the bisector of O1HA. So I'm gonna say implies after an angle chase. That's because okay, yeah, so I'm going to fill this in the end, and then we also need to show that HE is parallel to AC. O1HE equals EHA since they're equal to O1UE. Oh, okay, that's really easy actually then. So yeah, I like that. So that's much simpler. So we have angle O1HE is equal to angle O1UE is equal to angle EHA. We don't need the 90 part. So okay, so we know that that's an angle bisector. And then we can also show that HE is parallel to AC. Because angle EHA, yeah, that's because BH is perpendicular to HU and BH, yeah, okay, so it's really that simple. So BH is perpendicular to HU and BH is perpendicular to AC, and so that implies HE is parallel to AC. Okay, so how do we show that these are how do we show that O1? I'm going to delete O for now. How do we show that O1 E and O2 are collinear?
That is just a property of the trapezoid UBHA. Since O1 is the midpoint of BU and M is the midpoint of AH.
Ah, I like it. Okay, very nice. So in trapezoid BUAH, we have O1 is the midpoint of UB. M is the midpoint of AH. So that implies O1 E O1E, M, and O2 are collinear. And then similarly, F is on this line. Okay. Let me put these side by side. So it'll be done in just a second. All right. Oh, it should be D, not F. And then once we do that, so that means that AEHT is a parallelogram. And then we have these two equalities, but ME is equal to MD. And so that means XH over XC is YH over YD. And so then that solves it. So we have ME equals MB, means that XH over XE is equal to YH over YD. And that means that XY is parallel to O102. All right. Very cool. So I will move on to the next one. You just put that right there. This should be XH over XE. All right. So let's go on to the next.